Okay, so for this example, for this last example, for the notes, we're asked to find the compression, right? Given this situation with a spring, right? So the compression we're really looking for would be this part right here, the HB, which would be the height, right? That would be the compression, given that this is the floor, right? Okay, so let's start looking at A and B, right? This is A, this is B. So with A, we know that the mechanical energies of each other are equal. So it's basically a similar problem we did before. You have your this is your kinetic energy plus your potential energy of A plus the elastic energy, right? And the same situation in B, same exact situation. But now when we start looking at the problem, we can start to see what is there and what isn't, right? So this is something that's given to us too. This was what was given to us. We have a velocity of A is 10 meters per second, K is 1 n/m, and the mass is 1 kilogram. So we start looking. So all that we, in reality for A, all that we really have is the kinetic energy, because there is no elastic energy for A because it's elongated and stuff, and there is no potential energy because it's on the floor. If you look at it, it's on the floor, so there's no potential energy, right? So that's that. And for B, yes, for B, there's no kinetic energy. There does seem to be there is potential energy, and there's some elastic energy, right? And remember, what we're looking for is the compression, and that's HB. That's this one right here, all right? And the elongation is going to be HB, just HB squared, right? Okay, so once we plug in the numbers, once you start plugging in the numbers, you solve this, would give you 50. This is the 10, this is referring to the it's just referring to the mass times the gravity, and then you have HB plus half of HB squared. So now we end up with a quadratic formula, right? We end up having to use the quadratic formula, and once you do, you set it up like this, and you should get around 2.5 meters as the height, but also is considered as the compression, 2.5 meters.